In this video, we are going to work on evaluating composition functions that have two different trig functions involved, meaning like the last video was sine and sine, cosine and cosine, tangent, tangent with the inverses. Now we're going to mix them up. All right, so let me show you. These are done a bit different than the last. So I'm going to write the problem real quick. First thing we're going to focus on is just that inside, just like in the last ones. Let's focus here first. All right, so I know that this cosine, I can go ahead and make a triangle here in the first quadrant. I know it's in the first quadrant because 4 over 5 is positive. I'm going to go ahead and draw my triangle. This is going to help me out to figure these out. I have a right triangle there. And then I'm going to put a theta here. What I know this is going to end up being is this is going to be sine of theta, right? Because when I plug in a ratio, I get the angle associated with that ratio. Well, my ratio with this triangle is going to give me a theta angle. Now I'm going to use cosine. That cosine is cot, another hippie, right? So it's adjacent over hypotenuse, so it's going to be 4 over 5. Now, you could use the Pythagorean theorem here to find that third side. Hopefully, at this point, you guys are recognizing this triangle. If not, please run the Pythagorean theorem real quick. It turns out to be a 3. Well, now I have a triangle. And now I can base my work or my next answer on this triangle. They want sine of that angle. Well, sine is some old hippie. So I have that. So sine of that's going to be opposite over adjacent, or hypotenuse, sorry, which is 3 over 5. We're done. So this comes down to doing a triangle. I think the directions up there starts using some like formulas and stuff. I don't like that. I like to resort everything back to my triangle. Because 6 months from now, you're probably not going to remember that's equal to that. Even though it makes sense, because that's how this is the formula to find that 3. I just don't like formulas because you guys are good at the Pythagorean theorem. You have been doing it for a long time now. Right, let's look at the second one. I got cosine of tangent -1 of 5 over 12. We're going to focus on the inside first. So this inverse tan is going to give me an angle. So I know this is going to be equal to cosine theta. So let's draw it. 5 pi over 12 for tangent. That's going to be in quadrant 1. It's positive. So I draw my triangle. Best I can. It's kind of hard to get straight on here sometimes. So here's my triangle. Here's theta. And they told us tangent. Well, tangent was tripping on acid, right? That's how we memorize it. So opposite over adjacent. So it's 5 over 12. And then if we do the Pythagorean theorem here, again, with the legs, 5 squared plus 12 squared, and we do that, we're going to end up getting a 13 on this other side. So now, all we need to do is evaluate cosine given that triangle. Well, cosine is cot, another hippie, so adjacent over hypotenuse. So that angle, that ratio, is going to be 12/13. Again, no formulas. All I'm doing is drawing what the picture, sorry for that, the expression tells me to write around my triangle. I find my third side, and then I reevaluate the new trig ratio. I have a few more here. Let's take a look at this one. So sine of tangent, -1, 7 over 4. And we're going to focus on the inside first. Right? On the inside, okay, it's 7 over 4 for tangent. It's going to be quadrant 1. So here's my triangle. And then I know tangent is opposite over adjacent. So it's going to be 7 over 4. And I'm going to have to do the Pythagorean theorem here because it's not a clean one. So it's going to be 4 squared plus 7, one I don't know anyway, equals c squared or h squared, whatever you want to call it. This is going to be 16 plus 49. I put 14. 49 equals c squared. And that's going to be 65 equals c squared. Which means c, since it's the hypotenuse, it has to be positive. It's going to be square root of 65. So I know this thing is equal to sine of the angle of my triangle. And then sine, if I look at sine, it's going to be 7 over the square root of 65. We made a triangle, used the information that they gave us to fill up the triangle, and then we found the ratio on the outside. All right, let's take a look at the next one. I got cosine of sine, inverse sine of 7/9. Right? Sine is positive in the first quadrant, so I'm going to put my triangle in the first quadrant. There's my right triangle. And then sine is opposite over hypotenuse. So I know this is a theta, and I have a 7 over 9. And I'm going to have cosine now, theta. So I need to now find that third side so I can find theta. So I'm going to use the Pythagorean theorem here. 7 squared plus x squared equals 9 squared. So that's 49 plus x squared equals 81. And then x squared equals 32. And x is the square root of 32. I could reduce it if I wanted to. Lumen's probably going to want you to do that. You can use a calculator, or 16 goes into it, so it's going to be 4 root 2. You could use that as well. So cosine would be radical 32 over 9. That's it. All you got to do is draw the triangle. Everything comes back to those triangles and knowing your trig ratios. All right, I have 2 more. All right, we have cosine of sine inverse sine of x over 3. And then they give us this. X is between -3 and 3. So they want us to find a simplified expression, probably without the cosine inverse cosine. So, again, we draw a triangle. I'm going to put it in the first quadrant because the numbers are positive. Right? And then sine is opposite over hypotenuse. So it's x over 3. I have a theta. And then let's put a here. All right, so this is going to be cosine theta, right? The plugging in a ratio into an inverse function gives me an angle. And then now I'm going to have to find cosine. I don't want a. I want to figure out what a is. So a squared plus x squared equals 3 squared. And then I'm solving for a here. A squared is equal to 9 minus x squared. I squared the 3 and then minus x squared. So a is equal to the square root of 9 minus x squared. Well, since x is between -3 and 3, well, that works here as well. So this is going to be, that's what a is equal to. Cosine then is going to be the square root of 9 minus x squared. That's what this side is, right? That's what a is, over the hypotenuse 3. And we can leave it there. We don't even have to plug in the -3 to 3. I mean, how would we do that? All they're saying is it has to be between there. If you look at the function too, if it's bigger than 3 or smaller than -3, it's actually going to give me the square root of a negative. So it wouldn't work out anyway. Right? That's it on that one. It's the same idea, except for we just don't have all the numbers. Right? One last one here. I have sine of inverse tan of 4x. And that's going to equal sine of theta, right? I'm going to draw a triangle. And my tangent, they said 4x. So there's it's kind of crooked, but bear with me. It's a right triangle. And we know this is theta. And then they say tangent. Remember, tangent is opposite over adjacent. It's going to be 4x over 1. I know that's kind of weird. All right, we have to find our third side. I'm going to call it c. So we're going to have 1 squared plus, and then we got to be really careful here. It's the whole thing squared equals c squared. So I get 1 plus 16x squared equals c squared. Right? Then if I solve for c, c is going to be the square root of 1 plus 16x squared. That's what this side is. Now we need to find sine. Sine is opposite over hypotenuse. So it's going to be 4x over the square root of 1 plus, or 1 minus. Some of you guys are dying that I made that mistake and I didn't catch it till just now. 1 minus, because I have to, oh, no, it's plus, okay. Whew, never mind, I didn't make a mistake. I made a mistake about a mistake. So we get that. And that's what that is going to be there. X's have to be between -1/4 and 1/4, because if they're not, then I have an issue here. We're going to have some issues there. Okay, that's it.